Welcome back. I'm Jason Grindstaff, and in this video series we've been looking at some basic statistical concepts that look at, in the first video we looked at measures of central tendency. In one of the other videos we looked at the spread of scores or variability, and today in this video we're going to be looking at a confidence interval. So a confidence interval essentially gives us a bandwidth around which to be more confident about our reported statistics. So in this case, one of our early measures of central tendency that we came up with for our satisfaction in at a college or university upon graduation, we came up with our mean, we remember, of 3.6. So in essence, a confidence interval is going to allow us to say that we don't know necessarily, we're not 100% confident that the actual average or the actual mean of all of the total population of the graduating seniors is actually 3.6, because in essence we have a sample. So in reality, this 3.6 is just a parameter of what we believe might be the true mean. So in essence, our confidence interval is going to allow us to say that instead of 3.6, we can get a bandwidth around that 3.6 and say we're in a certain percent confident. So maybe we want to say that we want to be 95% confident in that average. So let's take a look at confidence interval and see how we come up with that bandwidth. So in essence, our formula for confidence interval, which we're just going to abbreviate as CI. We're going to have some kind of an observed statistic, okay? We're going to have some kind of an observed statistic, all right, plus or minus. We're going to have some kind of a standard error times our confidence value. And so let's break down this formula, what we mean by each of these terms. So here with our observed statistic, in essence we're talking about in this particular case, we're talking about our mean. For our standard error, how do we calculate that? Well, that's going to be our standard deviation. And if you remember back from the previous video, I think we came up with our standard deviation of 1.14. And we know that we have an N5. So it is our standard deviation divided by the square root of the n. And we'll calculate that in just a moment. And then our confidence value, okay, we're actually going to get that from a t-table. And you can easily look these up on the internet. Many stats books are going to typically have them in the back of the appendice. So when we work with that value, just know that we're getting that from a t-table. So in this case, get that in a t-table. So in this case, let's start with our observed statistic. All right, so we're going to have 3.6 plus or minus our standard error. And so our standard error is going to be 1.14 divided by the square root of 5. And that value, what we're going to get for that is going to be 0.51. All right, so now that we've got the standard error, we can insert that right here. We get 0.51, and we're going to need to come up with this t-table value. In order to be able to do that, when you look at a t-table value, you're going to need to know two numbers. You're going to need to know the alpha level that you set. In other words, how confident do you want to be in your statistic, and you're going to need to know degrees of freedom. For this formula right here, our confidence interval, observed statistic plus or minus the standard error times the confidence value table value, our degrees of freedom is going to be n minus 1. Okay, so in order to be able to look this value up in that t-table, you're going to need to know alpha, and in this example we're going to set alpha at 0.05. So in other words, we want to be 95% confident in our statistic. And you're going to know degrees of freedom, which we've already calculated over here to be 4. when you look that value up, it's going to give you your confidence table value. And in this case, that's going to be 2.78. All right. So as we work this out, we get 3.6 plus or minus 1.42. So what does this value tell us? 3.6 plus or minus 1.2. In essence, what it's telling us is that on the low end and on the high end, if we were to take 3.6 minus 1.42, that'd be our low end, and then 3.6 plus 1.42, in essence, that's telling us that we believe that we're 95% confident, or we're 95% sure that our true average, our true satisfaction average of our graduating seniors falls within that bandwidth. Now let's take a look at, before we finish up, kind of what happens if we were to calculate our confidence interval at 90%, 95, and 99%. So I went ahead and calculated these out at our various alpha levels. So in essence, our alpha value of 0.1, which would be 90%, 0.05 is 99%, and then 0.01 would be at a 99% confidence. And so if we calculate out those confidence intervals, what we see here is that for each of them, we still have obviously the same mean, plus or minus 1.09, 3.6 plus or minus 1.42, and then 3.16 plus or minus 3.5. And so when we look at this, what we end up seeing is that in essence, as we become more confident, as we move from 90% confident to 95 to 99% confident, as we become more confident, that bandwidth has to increase. To put it another way, if we only wanted to be 50% sure in our sample average, we could come up with a very, very small confidence interval, or that bandwidth around that mean. But as we become more confident or want to increase that confidence level, then that bandwidth needs to increase. So over the course of these 3 videos, what we've been able to do is we've been able to take a look at some simple statistics that we can begin calculating, some descriptive statistics. In other videos, we might take a look at some of the inferential statistics, or comparing groups to one another. But in this 3-part video series, we looked at introductory descriptive statistics, and we've looked at measures of central tendency, being our mean, median, and mode. We've looked at measures of variability, and in there we looked at our range, standard deviation, and variance. And in this video, we looked at our confidence intervals. So go back and review with those, practice with them. And as I mentioned before, statistics is very much like a foreign language. You just got to practice with it and practice with it to get better at it. So good luck. Keep practicing.